Hi everyone, welcome to Focal Academy. See this problem. Here how to find source current IS. So this is a source current IS, how to find it. So if voltage source, this voltage source supplies 2.5 kilowatts and 0.4 kilowatts where having leading. How can you find this current IS source? This is a problem. At first step, find the current directions. So at this node, find the current directions. So for this node, the three branches are connected. So this is the first branch, second branch, third branch. So from this branch, the current will be entering in this verse. Means this is the direction of IS. Next, from the source, for the voltage source, we know that the current direction is always from positive to negative. That means it moves like this. So this is the current direction for this branch. Now this is the outgoing branch having only load. So let's consider if the current is IS, this is I2 current and this is I1 current. So according to KCL theorem, at node incoming currents means sum of all incoming currents equal to sum of all outgoing currents. So here IS and I2 are the incoming currents, I1 is the outgoing current. So it becomes IS plus I2 equal to I1. So from this we get IS equal to I1 minus I2. So let's consider this is equation 1. So from this equation, if we know I1 and I2, so from that we can easily find source current IS. So first of all, find current I1. I1 is the current passing through this branch. So if you know the overall impedance of this branch and voltage across it, then we can easily find I1 by applying Ohm's law. So let's consider in this branch the impedance is ZL and the voltage is across, it was connected, this is the voltage source, means this is the voltage across this branch. So voltage is VL, that is 120 volts. Next, impedance ZL is 8 ohms plus impedance of inductor is J12. By applying Ohm's law, we get I1 equal to VL by ZL. So here VL is the voltage at this load, that is 120, because it was connected across voltage source, that is 120. So that was only supplied to this branch, that is 120 by, and ZL is the impedance of this branch, that is we got 8 plus J12. So by using calculator, by simplifying this, we will get 4.615 minus J6.923. Now we got current I1. So if you know I2, then we can find IS. Now how to find I2? So I2 is the current in this branch, means due to source. So according to power law, means power formula, we know that power equal to V into I. So for this voltage source, the power is complex power. So that is, let's consider as S equal to V into I star, means conjugate of current I. So in this plan the current is I2. So take it as I2. So from this equation, we will get I2 equal to complex power by voltage. So this is a star conjugate, I2 star equal to S by V. Now first of all find S, that is the complex power. So S is nothing but the complex power equal to P plus JQ. Here P means real power, that is given as by the source supplied by 2.5 kilowatts. So it can be written as 2.5 K means 2500 watts. So this is P, and Q means reactive power, that is given as 0.4 into K, nothing but 400 VAR. So it is nothing but Q. Now substitute here. So 2500. So here reactive power is given as leading power. So that's why I take it as here minus. So minus, and QL is 400, that is J 400. This is yes. Now substitute yes, and V is the source voltage, this is Now substitute in the equation, we'll get current I2 star. So it becomes I2 conjugate equal to S is 2500 minus J 400 upon, and voltage is 120. By simplifying this, we will get I2 star equal to, means I2 conjugate, nothing but conjugate, it becomes 20.83 minus J 3.333. So it is a complex number, but here we want current I2, so apply conjugate, it becomes I2 equal to, means minus become plus, that is 20.83 plus J 3.333. So this is I2 value and this is I2 conjugate. After applying conjugate, we will get this is I2. Now we got I1, this is the I1 equation. Let's consider equation 1, and this is I2. Now substitute 1 and 2 in this equation. So let's consider it is 2 and 3. Substitute 2 and 3 in equation 1. We will get source current is equal to, means I1 minus I2. So both are complex numbers. Just by subtracting that, we will get minus 16.22 minus J 10.256. We got source current in complex number. We can convert into phasor form. That is, find the magnitude for this complex number. That is IS equal to, so magnitude will be 19.19 and phase angle is minus 147.69 degrees amperes. So this is the current, that is source current for the given problem. And this is the process of simplification. Thanks for watching. Please subscribe, like, share. Thanks.